All right, so today we are going to talk about solving systems of equations, but we're going to use a different method, and I'll tell you about the method in a second. But what I would like you to do first for me is I'd like to review the graphing method, and I would like you to solve this system using the graphing method. Your first equation is y equals 2x plus 3. And your second equation is x plus 3y equals 1. So graph those two equations and tell me what the solution is. So pause the video and then you can figure it out, and we'll come back and we'll take a look and see if you did it correctly. All right, so let's see how you did on this one, and let's see if you got it right. If you did it correctly, you started with graphing the y equals 2x plus 3, and you probably went up to the 3 and graphed the 3. And then you would say from the 3 you went up 2 and over 1 to get that. And I'm just going to do a couple of quick little additions here. And I'm going to graph that line. There we go. And then you hopefully for x plus 3y equals 1, if I let x equal 0, y was 1/3, which didn't help me much. But if I let y equal 0, I know x is equal to 1, which is good. And then I know the slope is negative a over b. Remember, my slope is negative a over b, which in this case is negative 1/3. So I go down 1 and over 3. And I'm just going to do a quick little few more here. And then I'm going to draw my line. And so what did you get for your answer? Well, the problem is, and if we look at this really carefully, the problem we get is that it did not cross at a nice number. Now, some of you are probably saying, well, it crossed at negative 1, 1, but it did not. That is not where it crossed. It actually crosses a little bit to the left of negative 1 and a little bit above 1. So, in all honesty, there's no way I could even think about what the answer is to this. I don't even know. I mean, you can't say it's a fourth or a third or a half or an eighth or a 12th. I don't know the answer to that. So, where graphing works sometimes, it doesn't work all of the time. So let's take a look again at this. Y equals 2x plus 3 and x plus 3y equals 1. And I'm going to resolve this, and I'm going to try to solve this, but I'm going to use a different method. And this method, which we are going to talk about, is actually called solving systems by substitution. You see, in substitution, I actually have some very important information. And actually, if you look at the problem here, it tells you some very, very important information. It gives you some great information. As a matter of fact, that first equation is what gives it to me. See, the first equation says y equals 2x plus 3. It tells me that y, the variable y, is equal to 2x plus 3. See, here's the thing, folks. You got to get it out of your mind that y has to be some number. In this case, y, the variable y, is equal to an algebraic expression. And like we've done in the past where we substituted a number in for the variable, this time I'm going to take what y equals and I'm going to substitute it in for y. And that's going to give me x plus 3 times what y is. Well, y is 2x plus 3. And that's going to equal 1. So now I have an equation, nicely, that has one variable. So now I'm going to solve for that one variable. Well, I guess to solve this, I have to start by distributing the 3. X plus, see, 3 times 2x is 6x, and 3 times 3 is 9, equals 1. And let's see, x and 6x is, let's see, that's 7x plus 9 equals 1. Subtract 9 from both sides, and I get 7x equals negative 8. And if I divide both sides by 7, I get x equals negative 8/7, which, for our purposes of discussing that, is really negative 1 and 1/7, which, if you remember our graph, would be to the left of negative 1. I never would have guessed that negative 8/7, negative 1 and 1/7 could even be a possibility. Now the question is, how do you find out that's what x is equal to? So how do I find out what y is equal to? Well, that's simple. I can take what my x is and substitute it back into one of the equations to figure that out. So I can go, for example, y equals 2 times, let's go negative 8/7 plus 3. And let's see where we can go from there. From here, I know that y is equal to, let's see, that's going to be negative 16/7 plus 3. And let's see, 3, I need to put that over 7, so this is really y equals negative 16/7 plus 21/7, because that's equal to 3. Which means y is equal to, let's see, negative 16 plus 21. That's going to be 5/7. So my answer then would be, and I'm going to have to kind of come over here, I'm running out of space here, negative 8/7 and 5/7. And there's my answer. That is the solution to the system of equations. Not a nice answer, but it is the answer for it. So that's kind of how you would do substitution. Now I kind of made that problem up, which is why it didn't come out nicely, but I'm going to give you some nice ones to try here and see how well you do with it. So let's do another one, and we're going to do this one together so we can see what happens. Y equals 2x plus 5 and 3y minus x equals 20. So I have, in one of my equations, I have a variable solved for. And in this case, we're talking about what y is equal to. I know y is equal to 2x plus 5. So I'm going to take that and I'm going to substitute that in for y. So what I end up getting is 3 times, what is y? Well, y is 2x plus 5 minus x will equal 20. So now, to solve this, I distribute the 3, and I get 6x plus 15 minus x equals 20. Well, I'm going to do two things at once here. I'm going to combine my 6x and negative x together, and I'm also going to subtract 15 at the same time. And when I do that, 6x minus x is 5x. That cancels. And 20 minus 15 is 5. Now, of course, I divide both sides by 5, and I get x is equal to 1. So now I just plug that 1, which is nice, back into one of the equations. Well, this is the easiest one. Y equals 2x plus 5, which would be y equals 2 times 1 plus 5. And 2 times 1 is 2 plus 5. So y is equal to 7. So then my answer is 1, 7. And that's the ordered pair. That is the solution to the system of equations. So let me give you one to try and see how well you do. All right, so here's one for you to try. I was trying to find a nice one for you. And the one I was originally thinking wasn't so nice, but let's do this one. X equals 3 minus 4y and 2x minus 3y equals 17. All right, pause the recording and try this one and see what you come up with. All right, welcome back. Let's see if you got it right. And I know I kind of threw a little curve at you on this one because I actually gave you what x was equal to this time. So really you were substituting in for x in this case. And you're replacing x with 3 minus 4y. So I get 2 times 3 minus 4y minus 3y equals 17. So now if I distribute the 2 out, I get 6 minus 8y minus 3y equals 17. Correct? And then let's see what happens here. If I subtract a 6 from both sides, and I combine my negative 8 and negative 3 together, I get negative 11y equals 11. Divide by negative 11 on both sides, and I get y equals negative 1. And that's what y is. So then, to find x, I'll just substitute that back in for y, and I get x equals 3 minus 4 times negative 1, which is really x equals 3 minus negative 4, which we all know is 7. So I get my ordered pair is 7, negative 1. Let's just take a simple one for a second. Let's go back and take a very simple one. What if I told you this? Y equals x, that's not an x, let's try that again, x plus 8, and I told you y is equal to 2. Pause the video and try this one for a second. All right, let's see how you did. Y is equal to x plus 8. Substitute that in for y. Okay? So x plus 8 equals 2. Okay? So I subtract 8 from both sides, and I get x equals negative 6. So I know x is negative 6, but you know what? I don't need to do any more because it already told me y was equal to 2. So my answer is negative 6, 2, because it just told me y is equal to 2. I didn't have to do anything more with that one. Now, take a look at this one. And this one gets a little bit trickier for multiple reasons. This one's a little trickier. But let's talk about it. 3x plus y equals 10, and 3x equals negative 10 minus y. Here is where this one gets a little bit trickier because I don't have one variable solved for. In order to use the substitution, you have to have one of the variables by itself. And I don't have that in here. I have a 3x plus y equals 10. I have 3x equals negative 10 minus y, but that doesn't solve for anything. So what probably I need to do is take this equation here and solve it for y. So 3x plus y equals 10. And if I subtract the 3x from both sides, I get y equals negative 3x plus 10. Now I have a variable solved for that I can substitute into my equation. And when I do that, I have 3x equals 10, negative 10, minus negative 3x plus 10. Well, I'm going to have to distribute the negative there. So 3x equals negative 10 plus 3x minus 10. Let's subtract 3x from both sides. I don't like the number and variable on the same side, and there's a variable already on the other side. 3x minus 3x is 0 because they cancel each other out, and canceling each other out leaves me with a 0, equals negative 10, and negative 10 is negative 20. Uh-oh. Can 0 equal negative 20? I don't think so. So in this case, there is no solution. There is no possible answer for this one. All right. I'm going to leave you with one more. And this last one is y equals negative x minus 3 and y equals 3x plus 1. So pause the video and try to solve this equation. Okay, let's see how well you did with that. I'm going to take this y and I'm going to substitute it in for that y. So I get negative x minus 3 equals 3x plus 1. Well, let's see. I think if I add an x to both sides, and I'll subtract 1 from both sides, those cancel. That's negative 4. This is 4x, and those cancel out. So I get negative 4 equals 4x. Divide both sides by 4, and I get x equals negative 1. Well, there's my x. So now I need a y. Y equals, and doesn't matter which equation I use, it actually doesn't. So 3 times negative 1 plus 1, I'm going to use the second equation. So y equals negative 3 plus 1, or y is equal to negative 2. So my answer is negative 1, negative 2, because remember the x always comes before the y in an ordered pair. So it's negative 1, negative 2. And that's how you solve systems of equations using the substitution method. You replace a variable in one equation with the variable from the other. You replace a variable in one equation with the other equation is what you're doing. I want you to try the edge elastic assignment, and then I want you to come tomorrow and we will see if you have any questions, and we'll try more of these tomorrow during our Zoom meeting. All right. Have a good night. Talk to you later.